Hello everyone, I welcome you all to the live solution discussion of ISRO examination by conducted by ISRO, and here we are live in ACE Engineering Academy, right, and we are on the platform of ACE Online. So I welcome you all for the solution discussion of all the questions, right. Here we are from the team of Mechanical Engineering in ACE Engineering Academy, myself Shankar Wadne, and every sir will discuss each and every question in detailed manner, right. So let us begin, right.
Hi, I'm Dr. Sharma. I take up heat transfer.
Guys, myself Hazrat, I'm taking EM and strength of material.
Hi students, I am Mala Kondaya, will take the thermal part.
Hi dear students, I am Mohammad Vaidullah. I'll be taking theory of machines and machine design.
Hi, I'm Kaushik. I'll be taking industrial management and operations research.
Hello students, myself I am D. Srinath. I will be taking material science.
So let us begin. Yes, sir. Okay. See, okay, let us discuss now. See, we are here with mechanical set C paper. Okay, and let us see the weightage analysis. Here in this paper, if you discuss the weightage, thermal questions, thermodynamics, from the thermodynamics, if you find 9 questions, and if you check the notebook, each and every question was asked from the ACE Engineering Academy notebook only, right. Then heat transfer 9 questions almost. Fluid mechanics, as expected, every year fluid mechanics weightage is more, 14 questions were there. Then strength of material 7 questions, theory of machine, yes, 11 questions, right. Then machine design 4 questions are there, industrial engineering and operational research 3 questions are there. Then material almost from production technology, yes, it is the highest weightage subject for GATE as well as for ISRO also, right. So 14 questions are there. Then material science 5 questions, then mechatronics 5 questions, and engineering mechanics, mechatronics 1 question, and engineering mechanics 3 questions. And yes, this is the common part, that is mathematics and aptitude 15 questions, right, 15 questions. So total 95 questions. Today they conducted the exam, and if you see the questions, right, questions are very simple. If you check ACE Engineering Academy class notebooks, each and every question as it is, by changing the data, you will find in notebooks, right. So every question was doable, every question we can say. So we expect more cutoff this year. So I welcome to the, yes, Hadrat Ali sir, please come and please discuss the part.
Yeah, hello guys. Let me start with EM and strength of material. A rocket is launched vertically up. It attains the velocity of 200 meters per second at an altitude of 1.125. At this point, what happened is its booster stage is separated without any relative velocity. Then what is the maximum altitude? And he's asking what is the time taken to hit the ground. These are two questions, guys. What you can do is, so very simple. Assume this is the rocket. The rockets are having the boosters on the side. But here what happened is, at the elevation of how much? 1.125 kilometers, it has separated. At the time of separation, what is the velocity of this booster, guys? 200 meters per second. So my initial velocity is 200 meters per second. The question is asking is, how much height it can able to go, then how much time it will take from starting to ending, guys. From this point to here, where it hits the ground, what is the time taken in this process? Direct to Suvat equations, guys. How you can find out the Suvat equation? First one, how much height, this height, it can able to go. Let me check it, guys. What is the formula you can able to use it? Yes, at the maximum height, velocity equal to 0. So it should be how much? V square minus u square equal to 2as. Here, final velocity equal to 0. Initial velocity how much, guys? 200 square. That equal to 2 into acceleration. It is going upward direction, should be how much, guys? Minus g. So minus 10 into displacement, guys, s itself. So how much the displacement is coming, sir, here? S equal to, I can say, S means h, guys, 2000 meters. Which means it can able to reach a height of 2000 meters, but he's asking how much altitude. So 2000 meters plus or 2 kilometers plus 1.125. Total how much, guys, anyone? 3.125 kilometers. So, but here again problem is, guys, B and D having the same altitude, but difference is time. So how can you able to guess it? First you can able to do it. First, time taken to reach from here to here, and again time taken from here to here, guys. How can you find out? What the formula? You know S that equal to, or I can able to find out V equal to U plus AT. V equal to U plus AT. Typical Suvat equation. Final velocity equal to 0. Initial velocity 200, guys, plus A. How much? Minus 10 into time t. So t equal to how much, guys? I can able to get 20 seconds. So 20 seconds is the time, guys. So definitely from here to here is coming 20 seconds. It will be definitely more than 20 seconds, guys. Without solving, I can able to say answer is 45 seconds, guys. If you want, you can verify. From here to here, you will get 25 seconds, guys. If you want verify with the help of the same Suvat equations, you can able to get. The right answer here is option D. Because from here to here is 20, this should be more than 20 definitely, guys. So answer should be equal to option D, guys. Next. Yes, this is a pretty straightforward question, but students feel little difficult, guys. But a boat is traveling at a speed of 40 meters per second. Assume this is the place where the boat is present. This is the place where the observer is present, guys. The boat is having a velocity this direction. How much, guys? 40 meters per second. And this is the angle theta he has given. This is the angle theta. Then I will briefly explain you, guys. If it is having a velocity of 40 meters per second, what is the angular velocity about the observer? That is the question they given. What is the angular velocity? What is the basic angular velocity formula? V equal to R into omega. Am I correct or not, sir? V equal to R into omega. But what is the V? If I assume this is the R, V should be perpendicular velocity, sir. This should be V perpendicular. How much this should be, sir? This is the theta. This should be also how much, guys? Theta itself. How much is coming, sir? Vt equal to 40 cos theta. Am I correct or not? Vt equal to Vt 40 cos theta. So I got this value. Then we are going to get R. This is the R value. How can you get this R, guys? Assume this is the 100. How much is given? 100. So it should be what exactly, sir? So I can write V should be equal to 40 cos theta R. R equal to how much, guys, I can write? Yes, 100 by cos theta into omega, guys. So what is the value of omega? So I can write 40 into cos square theta. But theta equal how much? 30 degrees, guys. It is root 3 by 2 means 3 by 4. Yes, by 100. It is coming as 0.3 radians per second. Straightforward question, guys. V equal to R omega. This is the R. How can you get the R, guys? It is R equal to how much, guys? 100 by cos theta, then omega. The right answer here is option A. The right answer here is option A is the right answer, guys. Next, the pretty straightforward question in our regular classroom notes. You can check our notes about the lifting missions. I clearly explained in the classroom also, guys, similar kind of question. Please check it. See, if this is the P, this should be how much, guys? If this is the P, this should be also P. Now, this is the P, this should be P. Then, how much should pull down? 2P. If this is pulling down by 2P, it's pulled up by how much, guys, anyone? 2P itself. Now, tell me, sir. If this side is 2P, this side is 2P, pulled down by how much, guys, anyone? 4P. This is pulled down by 4P. How much is pulled up, guys? 4P itself. If we take the free body diagram of 70 kilonewtons, what is going to happen, guys? 70 kilonewtons. This is 70 kilonewtons. Now, upward, 4P, again 2P, again P, guys. Total how much, guys? 4P plus 2P plus P, 7P. 7P by 70, guys, is coming P equal to how much, guys? 10 kilonewton. But he is not asking 10 kilonewton, guys. Asking what is the stress in the L. In this cable, what is the stress, guys? What is the stress formula? P by A. Am I correct or not, sir? Stress equal to P by A means 10 into 10 cube. Area how much, guys, anyone? With the side of square cross section as is given. 10 square. 10 square megapascal, guys, I am going to get. So answer is coming how much, guys, here? Yes, 100 megapascal is absolutely wrong answer. Why it is absolutely wrong answer, guys? Why? Because is the force acting is 4P here. So should be multiplied by 4. Should be multiplied by 4. It is a 400 megapascals. The right answer here is option C, guys. You should be very careful in which cable he is asking. In the cable L. In the cable L, load acting is 4P, guys. It is the 400 megapascals. That's good. A material has a Young's modulus of 200 gigapascals and Poisson's ratio of 0.3, then what is its bulk modulus? Pretty straightforward question, guys. What the formula you have to use it? Anyone? E equal to how much? 3K into 1 minus 2V, because asking the bulk modulus, guys. Three relations you have to remember, guys. E equal to 2G into 1 plus V, E equal to 3K into 1 minus 2V, E equal to 9kg by 3K plus G. I hope you remember, guys. So E equal to how much he has given? 200 gigapascals. That's fine. That equal to 3 into K I want you to find out. So 1 minus Poisson's how much is 0.3. So 1 minus 0.6. It is coming as 3 into how much, guys? 0.4. 0.4 means I can able to make it 2 by 5 is the 0.4 into K. Then it become how much, guys? K equal to how much, guys? 100. 500 by 3 is approximately, guys, 166.7 gigapascals. That's it. The right answer here is option D. Next, please check this question. Pretty straightforward question, guys. A rod has a coefficient of thermal expansion. Alpha he has given. And Young's modulus he has given, guys. Young's modulus is given as a 200 gigapascals. It's fitted snugly, tightly between the supports as shown in the figure. What is the stress induced in the rod if it is raised by 20 degrees Celsius? It is actually previous question of gate question, guys. You can check the previous year gate question. You will see this kind of question, guys. If they try to heat it, what happens? It want to expand. But when try to expand, what happens, guys? It will try to compress the spring. Am I correct or not, sir? Try to compress the spring, guys. When try to compress the spring will give you resisting force, guys. What is the resisting force offered by the spring? I can able to say, assume spring will give you force, resisting force in this direction. What the spring force equal to how much? K into delta. K in delta means deformation of the spring, guys. Then What is the stress equal to how much, guys? First, it should be compressive or tensile. It should be compressive, guys, because it is coming inside itself. The stress equal to how much is coming? Minus K into delta by area. Area how much, guys? Anyone has given? Area equal to pi by 4 d square. Pi by 4 into 100. So 10 square. 10 square means 100 I am going to get. Now, what is the K he has given, guys? 50 kilonewton per meter. Just put everything, guys. Minus 4 into K means 50 kilonewton per meter or Newton per mm I am going to get, multiplied by delta. Delta value how much, guys? Delta equal to L alpha T. L alpha T. This is equal to L alpha T, guys. Here L is how much, guys? Has given 0.5. In terms of mm, how much? 500. Alpha how much has given? 31.4 into 10 power minus 6 into T how much, guys? 20 itself by pi into 100. See, guys, pi, what is the pi? 3.14 into 10 times I am going to get. So directly, no need to use any calculator, guys. 100, this becomes this one. Just verify, I am going to get minus 0.2 megapascal you are going to get. The right answer here is option C, guys. I hope this is clear. It should be minus. Next, consider the following statements related to stress and strain. First, shear stress is always tangential to the face over which it acts. Definitely, sir. Always tangential, not normal, guys. First one is correct. Next, shear stress on the transverse pair of faces are known as complementary shear stresses. Definitely, sir. One will try to act upward, one will try to act downward. Both will be called complementary shear stresses. Next, shear strain is defined as the change in the right angle of the element measured in radius. Definitely, sir. Shear strain equal to change in angle measured in radius, guys. Check our notes. I clearly given the same statement as the definition for the shear strain, guys. Please go through it. The right answer here is all 1, 2, 3, guys. Next, a cantilever beam, straightforward formula for question number 3 in our booklet, guys. You please check the same question given, guys, in our booklet also. A cantilever beam carries a load W at the uniformly distributed load. Please check our booklet also, you will find the same question, guys. Question number 3, deflection of beams in our booklet. It is so assume Q Newton per meter. This Q into L, total load equal to how much, guys? Anyone? Q into L equal to how much? W. He has given that deflection at this due to UDL. This deflection equal to how much, guys? What the formula you know? Q L power 4 by ATI. It become what exactly, sir? W L cube by ATI. Because Q into L become what exactly? W. Now what the second part he has given? Same thing, he's applying a point load now. When you apply a point load, what is the deflection, guys? Point load has given W. This should be how much? WL cube by how much? 3EI. He's asking, this is delta 1, this is the delta 2. What is the ratio of delta 1 by delta 2, guys? Delta 1 by delta 2 become how much, guys? 3 by 8. The right answer here is option A is the correct answer, guys. Next. A pretty straightforward question of our classroom itself. A solid shaft of diameter. This is the solid shaft of diameter. How much has given? Capital D. And what the shear stress will be, guys? Tau equal to how much? 16T by pi d cube. 16T by pi d cube. Assume capital D. Now what he has done, he made into a hollow shaft which is also having a same outer diameter. Outer diameter is same, but inner diameter how much, guys? Anyone? D by 2. This is the capital D by 2. This is the D he has given, which means that what is the diameter ratio? Inside diameter by outside diameter. How much is coming, guys? 1 by 2. Then what is the maximum shear stress will be coming in this case, guys? This is what exactly is asking. Tau max equal that straightforward formula, guys. 16T by pi d cube into 1 minus k power 4. But we know that 16T by pi d cube equal how much, guys? Tau. So definitely I can able to say this is the tau by 1 minus 1 by how much? 16, it become how much guys? 16 by 15 into tau. It is equal approximately 1.0767 tau itself. So right answer is option A is the correct answer guys. Now please check this question. A tapering bar, this is the tapering bar having a diameter D1, D2, and I am having a prismatic bar having a diameter D. Both are subjected to same axial load. Then if the elongation is same, what relation between D and D1, D2 he is asking, sir. First let me take it guys. Isn't this is delta L1, this is delta L2. He mentioned that delta L1 must be equal to delta L2. Then what should be the relation between D, D1 and D2? Delta L1, how can you able to find out guys? Very simple, direct formula. PL by AE. What is the A here guys? Pi by 4 D1 D2 into E. Delta L2 how much guys? PL by pi by 4 D square into E itself. Here force is same, length is same, and same material itself guys. So what is the answer here guys? Tell me, because everything will be striked off, only these two will be equal. So D equal to square root of D1 and D2. So right answer here is option B guys. Next, a bar of copper and steel together forms a composite system. In our classroom notes, it's a case number 5 we discussed in our classroom notes guys. Please check it, composite system. One is this is the copper, this is the steel guys. Which one having more thermal expansion? Alpha of copper is more than alpha of the steel. What happened? Copper want to go more, but steel, what the steel will try to do guys? It will try to compress it further inside guys. So that is the reason copper will be under compression, steel will be under tension to keep final settlement at the equilibrium position guys. So steel will be tension, copper will be under compression. The right answer here is option B is the correct answer. Yes, thank you so much guys. I wish you are able to solve all the questions, because all the questions we can able to solve from our class notes itself. Wish you all the best. Thank you guys. Now.
Good evening to you all. I am Dr. Sharma here from ACE Academy. I am trying to tell about the solutions of your ISRO paper. If you see, there are 9 questions that have been given this time for heat transfer. I feel like it is must for those who secure the position for ISRO. Now, if you look at the first particular question, this particular question was asked on thermocouples, if you observe. That means it is transient heat conduction. It is asking you time. So, in transientness, whenever you are trying to measure temperature using thermocouples, generally thermocouple B diameter is very small, its thermal conductivity is very high, hence Biot number should definitely be less than 0.1. If not, you can calculate. But as it is a multiple choice question, as you are fighting with respect to time, all thermocouple systems are basically mapped into lumped heat capacity analysis, wherein you write T minus T infinity divided by Ti minus T infinity is equal to e to the power of minus h into As divided by rho v Cp into tau. The beauty of this particular question is, he said that determine how long will it take for thermocouple to read 99% of the initial temperature difference. That means response. 1 minus response is error. So, whenever you are writing it, error is 1 minus response, which is, say suppose if you are writing in terms of fraction, it is 1 minus 0.99, which becomes 0.1, 0.01. So, this is your error and this value comes out to be the error. So, 0.01 is equal to e to the power of minus. If you look at if you look at the values, say suppose H heat transfer coefficient he has given, convective heat transfer coefficient between junction and the gas is 200 watt per meter square Kelvin. H value is given. And then if you observe volume, this is volume, this is surface area. Volume divided by surface area is equal to R by 3. So, I will rewrite this value as H into 3 divided by rho R Cp into tau. H value is 200, density value is given 8500, specific heat is given 320 and radius 1 mm diameter. It is a spherical bead. That is why I have used volume divided by surface area. 4 by 3 pi r cube divided by 4 pi r square comes out to be r by 3. So, if you substitute, the substitution is 0.01 is equal to e to the power of minus 200 into 3 divided by 8500 into r 1 mm 10 power minus 3 into 320 into tau. Take logarithms on both sides. Log 0.01 is equal to minus 600 divided by, this value becomes 8.5 into 320 into tau. This value comes out to be 10.5 seconds. Within 10.5 seconds, the thermocouple will measure the temperature accurate up to 99% with an error of 1%. One of the beautiful questions in lumped heat capacity analysis, transient heat conduction problems. Well, let us roll out to the next question. See, when you have made these questions live, I need not tell you in an offline or online mode after the exam is over, but the way the questions were being given in heat transfer, he has given one numerical question tough where you are taking more amount of time, and in other particular question he has given it slightly more in a theoretical way wherein you can match up your time. The beauty of time management if you observe it. The temperature profile for heat conduction through a wall of a constant thermal conductivity in presence of a heat source. Whenever there is a heat source, of length, if you are taking 2L, this is totally generating heat per unit volume. In such situations, you are observing the profile to be a parabolic profile, T minus TW divided by T max minus TW is equal to 1 minus x by L square. Second order, where maximum temperature is observed here, the profile is symmetric on both ends. This is the wall temperature. Temperature at any location is T. So, it is a parabolic profile, answer is B. If you go to the next question, beautiful question, because whenever you are looking at forced convective heat transfer situations, in forced convection you have external flows and internal flows. Whenever you talk about external flows, the pressure gradients in the direction of fluid flow are absent, whereas in terms of internal flows you observe that there is a pressure gradient. And this is a problem wherein he has given a internal fluid flowing along a tube, and he has not given isothermal tube, rather he has given a constant wall heat flux. Whenever you are going for a constant wall heat flux, neither the wall temperature nor the fluid temperature remain constant, but the difference between the mean temperature as well as the fluid temperature remains constant all along. That is a fundamental aspect whenever you are looking at your constant wall heat fluxes. So, say suppose if you are trying to write Q dot is equal to flux per unit area is equal to H into wall temperature minus fluid mean temperatures. So, you observe that this particular flux divided by H is equal to TW minus Tm, and as it is a constant heat flux situations, the one which is towards your left hand side remains constant, because heat transfer coefficient is not varying, it is not. So, you clearly tell that the difference between the tube surface temperature and mean fluid temperature remains constant throughout the tube length. That is correct. That is the first point that we have to catch up. Why? Why it happens? Because the mean temperature, if it is temperature, this statement is wrong. Statement first would be wrong if you say it is temperature, but it is not just temperature, it is a mean temperature. We call this as a beautiful name, we call it as bulk mean temperatures. In fact, they should have used that word bulk. So, the bulk mean temperature of the fluid varies linearly along the tube length, correct. The surface temperature of the tube varies linearly along the length of the tube, correct. And neither the fluid temperature nor the wall temperature remains constant, they vary. So, he has given variable, but the difference remains constant. So, answer is D, all the above. I tell you, this is one area where always there are questions from last 7-8 years. I am seeing that a question is always asked from internal fluid flows, forced convection and constant wall heat flux situations. Then you say again, that is what I am telling you. If you observe it, your time management here, there is no time if you are done with our notes and our classroom interactions, as well as our mentoring sessions which students have attended. This is taking less time, even this is also taking less time. But when you come over here, oh, you observe a big paragraph. And if you observe it, he is saying that, let us read the question carefully. This is a question that they have asked from radiation. Now, what he is saying that there is a flat plate collector. Yes, that is correct. There is a flat plate collector, has a selective absorber of emissivity 0.2 and solar absorptivity of 0.95. See, what happens whenever you talk about this absorber, he is telling that it is a selective absorber. So, that depends upon the wavelength of that particular radiations, and he is saying that the absorptivity is selective absorber of emissivity of this is 0.95 and emissivity of 0.2. So, you should not be clear that as per Kirchhoff's law, in an enclosure at equilibrium you observe that ratio of absorptivity to emissivity remains constant, but this not have been attained any equilibrium situations. So, we will just go with this particular data. At a given time of the day, the absorber surface temperature is 125 degrees centigrade. So, this particular surface is at 125 degrees centigrade. So, plus 273 you add it. So, this comes out to be 398 Kelvin. And he is saying that when solar irradiation is 1150 watt per meter square, G, he has given value of G radiation 1150 watt per meter square. It is the amount, total amount of radiation that is falling on the surface per unit area. And this need not be direct radiation, it can be even reflected radiation from the other particular surfaces. That is what we have been learning when we deal about gray bodies. So, if you observe it, he has given 1150 watt per meter square. The effective sky temperature is -10. So, he is saying that there is sky over here, and this should be far above your Van Karman line, 100 kilometers above the surface. So, this is at -10 degrees centigrade, which comes out to be 263 Kelvin. But he is also saying that ambient air temperature is 30 degrees centigrade. So, up to some extent there is ambient which is at 30 degrees centigrade. This comes out to be 303 Kelvin. Assume heat transfer coefficient to be 1 watt per meter square Kelvin. So, he is saying that H is equal to 1 watt per meter square Kelvin, heat transfer coefficient. This is a problem wherein radiation is with participating mediums, and calculate useful heat removal from the collector. The sky radiation is in same spectral region as that of the surface emissions. Beauty. So, first let us see the amount of radiation that is falling on the surface. The amount of the radiation that is falling on the surface is G, and in that how much amount of it is absorbed? Alpha into G, that is 0.95 into 1150. So, this comes out to be 95 into 11.5, so many watt per meter square. So, this is around 1090 watt per meter square Kelvin. Now, this particular value, if it is in the absence of convective environment, and if it is in the absence of radiative heat losses, this should have been the total amount of heat that has to be removed from the collector, but it is not so. What it is doing is, the ambient that is present here is absorbing heat per unit area, which is TW, surface temperature, minus the ambient. Heat transfer coefficient is 1, surface temperature, say in centigrade and Kelvin, temperature difference remains same. So, it is 125 minus 125, or need not, you can directly go ahead, 398 minus 303. This is the amount of heat that is being removed by convection minus, and the amount of heat loss because of radiation is, say suppose Q dot because of radiation is epsilon sigma AS Ts power 4 minus sky to the power of 4. And as I am calculating per unit area, this value of emissivity he has given it as 0.2, sigma is 5.678 into 10 power minus 8 into surface temperature is 398 power 4 minus sky 263 power 4. This is loss. So, add these two, remove from this value, your answer is coming out to 767.2 watt per meter square. Very simple. The amount of heat that is being incident on the surface is being absorbed, irradiation into alpha will give you the amount of heat that is being absorbed. Then there is a convective environment, how much amount of heat is being removed? Remove it from the value of alpha into G, and then you remove the convective heat loss to the sky. So, this is a, you will get it. So, this value is 767, this is rank deciding question. I tell you why. It is taking more amount of time, and whomsoever attempts it has to do it correct. And this is beautiful question, I tell you, straight extracted from one of the very good textbooks, and even it is present in our material also. So, what is the name of the dimensionless number that characterizes the ratio of thermal to mass diffusivity? See, the ratio of, say suppose if you are looking at diffusivities, you have mass diffusion, you have momentum diffusion, you have a thermal diffusions. the ratio of momentum diffusion to thermal diffusion is Prandtl number. The ratio of your thermal to mass diffusivity is Lewis. This is alpha divided by DAB. This is Lewis number. And see, heat transfer is again extended back whenever you are looking at species concentrations. Then one more big question. I tell you how beautifully they are framing questions to see to it that you go round, beating around the bush. This is again one more rank deciding question. He has given a lamba chauda question. If you observe it, a shell and tube heat exchanger is to be used to condense 2.73 kg per second of saturated steam at 340 Kelvin. So, he is saying that there is steam condenser, and this particular steam condenser has to condense, mass flow rate of steam is 2.73 kg per second. Just check whether has he given HFG value. Check if he has given anywhere HFG. Yes, he has given latent heat of vaporizations 2.34 into 10 to the power of 6 joules per kg. So, you will know how much amount of heat has been removed. Rate of heat transfer is mass flow rate of steam into HFG. Till now, this is clear. Now, if you observe, don't go into your LMTD techniques because this is a sizing problem. This is not a rating problem. In heat transfer, heat exchangers, we have two types of problems. One is rating problem, other one is a sizing problem. This particular problem is a sizing problem. So, this is at 340 Kelvin. This is steam. This is also at 340 Kelvin. Water, cooling water is entering at around 15 degrees centigrade, 298 Kelvin, 273 plus 15, 288 comes out to 288 Kelvin, and this comes out 303 Kelvin. I do not know what is the mass flow rate of water. So, what I will do, I will equate it, assuming that balance is being done. This is equal to mass flow rate of water, specific heat of water into differential temperature of water that it has gained. So, this comes out to be mass flow rate of water is this value 2.73 into 2.34 into 10 power 6 divided by specific heat of water 4181 into 15. This will give you mass flow rate of water. After calculating mass flow rate of water, if you observe it, the thin walled tubes of 19 mm diameter are to be used, because in a shell and tube heat exchanger where specific volume of the fluid is high, it is pushed through the shell side. So, it is clear that cooling water is made to pass through the tubes. So, I will try to calculate what is the mass flow rate of water per tube. And continuity equation gives me. So, this gives me rho A V. Density is given 998, area is pi by 4, d square value 19 mm, 19 into 10 power minus 3 square into mean velocity of water that is flowing through the tube is 0.5 meters per second, 0.5. I know mass flow rate of water per tube, and I know what is the actual mass flow rate. So, mass flow rate total, I will call this as total. Total divided by mass flow rate of water per tube. This will give you number of tubes, and I made a calculation. It is coming out to be B 721. I am getting it 720.9. So, you can take it to be 720, the nearest value. So, answer is 720 tubes. In fact, when you look at condenser, it is very big. Shell and tube heat exchangers used in power plants. I think my My thermal engineering friend will tell you more about it rather than me talking about something in this. I was just touching the base. In forced convection, which of the following is true for Stanton number? Ratio of heat transfer to thermal capacity, because Stanton number is Nusselt number divided by Reynolds number into Prandtl number. If Prandtl number is equal to 1, then second statement would have been correct. It is the ratio of Nusselt number and Prandtl number. Wrong. Stanton number is ratio of Nusselt divided by Pislet or Reynolds into Prandtl, which is also equal to rate of heat transfer divided by heat capacity of the fluid. Heat capacity, mass flow rate into specific heat. Then, yeah, this is a surprising question. If you look at this particular, question, this question is asked again from radiation. I am telling you, this is again rank deciding question. I rate this as rank 1 question in heat transfer. You know why? This question was asked from non-enclosures. It is not asked from enclosure. In an enclosure theory says clearly that sum of all shape factors should be equal to 1, but this is a non-enclosure. So, whenever there is a non-enclosure, you go with graphical method. There is a method known as a graphical method. So, suppose in graphical method what you do is, this is surface 1 and this is surface 2. If this length is L1, if this length is L2, then join the cross strings. This string is L3, this string is L4. Join uncrossed string lengths. This is L5, this is L6. Then shape factor F1 on 2 is approximately equal to L3 plus L4, Hotel's cross string technique, minus L5 plus L6 divided by 2 times that particular length, which is maximum, but still here as he has specified 1 and 2, it is clear. So, what I will do, this point is joined here. When this particular point is joined here, L3 is equal to, say suppose if it is like this, then I would have joined these two and I would have said this is L3, but this point is joined here. When it is joined, L3 becomes 200. So, L3 is 200. And L4, if you observe it, L4 is, say suppose these 2 points you have to join, but as this point is joined here, this length becomes L4, and he has not specified, he has given this as 100 from the midpoint, this value is 100, so its hypotenuse becomes 100 root 2. This becomes 100 root 2. So, I will say that L4 is 100 root 2. Then, if you write L5, L5 is this particular end. So, if you join this end to this end, this becomes L5, this becomes 100 root 2, and L6 is 0. There is one particular point which is coincident. So, now if you substitute it, 200 plus 100 root 2 minus 100 root 2, numerator becomes 200 divided by denominator is 2 into L1 is 200 half. F1 on 2 is equal to half. F1 on 2 is equal to half. So, F2 on 1, reciprocity theorem, A1 by A2 into F1 on 2. Assuming widths to be same, A1 is 200 divided by A2 is 100 root 2 into half. This cancels 2 times, 2 get cancelled, this value is 1 by root 2. 1 by root 2 is 0.707, and you should always know clearly that no shape factor will be greater than 1. So, F1 on 2 is 0.5, F2 on 1 is 0.707. Answer is A. Really good question. and a hot metal sphere is suddenly immersed in a liquid bath at a much lower temperature than the hot metal sphere, quenching process. Under which of the following conditions temperature gradients in the metal sphere can be assumed to be neglected? He is saying that internal metal is conductive resistance. He is saying that under which particular conditions conductive thermal resistance is far less than convective thermal resistance. Our ratio of conductive thermal resistance to convective resistance is Biot number. This is possible only when Biot number is far less than 1. Answer is C. Transient. Second question. Oh, I think the questions are completed. Thank you very much. I may be slightly fast, but you are more faster than you can understand it. All the best. Thank you, and my friend Malakonde Garu will take over from me. Thank you.
Hello dear students, welcome to the IS online platform thermal part. Today's exam thermal part is covering 9 questions. Out of 9 questions, 7 are from thermodynamics, only 2 are from jet propulsion system. No question from either IC engines or refrigeration and air conditioning systems. Okay. Out of 9 questions, almost all questions are easy only. 2 are theoretical questions, 7 are numerical type questions. Okay. Let us take the very first question. Look at the question asking from the gas turbine cycle. You can also say the Brayton cycle. The question is asking like this. In a gas turbine cycle, the turbine output, that means turbine work is given. Turbine work is 600 kilojoules per kg and compressor work is 400 kilojoules per kg. 400 kilojoules per kg. If the heat supplied is 1000 kilojoules per kg, the amount of heat added 1000 kilojoules per kg. All are in kilojoules per kilogram. Okay. What he is asking is the thermal efficiency of the cycle. Very simple. As you know, thermal efficiency of the any heat engine equal to ratio between the net work output and heat input. The net work output equal to turbine work minus compression work divided by heat supplied or heat input. Look at the turbine work 600 minus compression work is 400 dividing by 1000. You know 600 minus 400 200, 200 divided by 1000. To get in percentage multiply with 100, it gives 20%. That is the answer. Look at the option D. Option D is absolutely correct. Very simple question, right? Straightforward question. The same problem is available in our material. Okay, na? Similarly, look at the another question asked for the boilers. In a boiler, feed water supplied per hour is 205 kilograms. That means mass of the water supplied is equal to mass of the steam produced 205 kilograms per hour. That is the amount of water supplied to boiler in 1 hour. Okay. While the coal fired per hour is 23 kilograms. Mass of the fuel bond equal to 23 kilograms in 1 hour. Net enthalpy rise per kg of water is, net enthalpy rise means, net enthalpy rise, ek minute, net enthalpy rise means enthalpy of the steam minus enthalpy of the feed water, that is given as 115 kilojoules per kilogram. And calorific value of the fuel, calorific value of the fuel is given 2050 kilojoules per kilogram. You are asked to decide the boiler efficiency. Very simple. As you know, the boiler efficiency equal to boiler output dividing by boiler input. From the boiler what we are getting? The steam. The boiler output is nothing but mass of the water evaporating multiplied by energy possessed by the water with 1 kg, that is H net, dividing by the input is heat supplied system, that is equal to mass of the fuel burning multiplied by calorific value. Okay. So, boiler efficiency is equal to the mass of the water 205 multiplied by H net is given 115 dividing by mass of the fuel 23 kg multiplied by calorific value is 2050 10 times T05 10 times, it is 11.5, 115 by 10 11.5, finally it gives 11.5 dividing by 23 into 100 to get in percentage, it is equal to 1 by 2, 11.5 dividing by 23, 1 by 2 into 100, it gives how much? 50%. That is the thermal efficiency of the boiler. Option C is absolutely correct. Is it not simple question? Very simple question. Similarly, look at the another question asked for the what Otto cycle. Calculate the ideal air standard cycle efficiency of Otto cycle for petrol engine. The cylinder bore given, internal diameter of the cylinder D is given 70 mm. 70 mm. I am making it in centimeters because clearance volume is given cubic centimeters, and stroke length given, piston displacement length is given what 100 mm, 100 millimeters, that is equal to 10 centimeters, 10 centimeters. And clearance volume, look at the clearance volume VC equal to 42.78. Look at the units, centimeter cube, cubic centimeters. Okay. Consider the ratio of specific heats, that is adiabatic index given, adiabatic index gamma equal to 1.4, and you are asked to take the 22 by 5 equal to 5, means 5 value equal to 22 by 7. So, some value is given log 2.5 base 10 equal to 0.4. As you know, Otto cycle efficiency equal to 1 minus 1 by compression ratio power gamma minus 1 into 100 for getting in percentage. For that we need to decide the compression ratio. The compression ratio RC equal to what? Swept volume plus clearance volume dividing by swept volume. Swept volume equal to area of the piston multiplied by stroke length. It is equal to pi by 4 into d square into stroke length. Substitute the values of diameter and stroke length for getting the swept volume, and also you can get the compression ratio. Compression ratio is approximately around 10, that is the compression ratio. Then you substitute that compression ratio here for getting the efficiency of the Otto cycle around 60%. I calculated to get 60%, that is the answer. Look at the options, option D is absolutely correct. Understood clearly? Yes. Similarly, look at the another question asked like this. Calculate the volume of 3 kg mass of steam, mass of the steam given 3 kilograms, 3 kilograms. At a pressure of 1.3 bar, pressure is given. The dryness fraction of the sample steam, the dryness fraction of the steam x equal to, dryness fraction x equal to 0.8. The specific volume of water at 1.3 bar is specific volume of the saturated liquid, generally marked as VF, given 0.001 meter cube per kilogram, and specific volume of dry steam 1.3 at the same pressure. Specific volume of the dry steam you can mark as Vg equal to how much it is given, 1.3 meter cube per kilogram. You are asked to decide what is the volume occupied by the two phase mixture, that is wet steam. As you know, specific volume equal to volume dividing by mass. From this, volume occupied by the steam equal to specific volume multiplied by mass of the steam. Okay. Here, since the steam dryness fraction is given, the steam is wet steam, the specific volume of the wet steam V wet equal to Vf plus x Vfg, Vg given, Vf given, Vfg you need to find. As you know, the Vg equal to Vf plus Vfg. From this you decide the Vfg value, Vfg equal to Vg minus Vf. You substitute that value here for getting the specific volume of the wet steam. After getting the specific volume of the wet steam, you substitute here specific volume of the wet steam multiplied by mass of the steam, gives the answer 3.1206. 3.1206, it is in meter cube. That is the answer, very simple question. Option B is absolutely correct. Okay. Similarly, look at the another question. It is asking like this. why specific impulse of a rocket engine increases in vacuum compared to sea level. You know, by the time the rocket is propelling in the vacuum region, there is no resisting force for the jet leaving from the nozzle exit. Therefore, the jet velocity is going to increase. When the jet velocity increases while the rocket is propelling in the vacuum region, the thrust force or simply thrust increases. Then that thrust force dividing by mass is called specific impulse because of the increase in thrust force while the rocket is propelling in the vacuum, the specific impulse increases. This thrust force increases due to increase in exhaust velocity. Look at the options. Combustion chamber pressure increases, no way combustion chamber pressure is connected to the vacuum. Mass flow rate of propellant decrease in vacuum, no, mass flow rate is remaining constant because the material is leaving from the nozzle is coming under steady flow device, it can maintain the constant mass flow rate. Exhaust velocity increases in vacuum, yes, absolutely correct. By the time the rocket is propelling in the vacuum, the exhaust velocity increases. Because of the increase in exhaust velocity, thrust force increases. Because of the increase in thrust force, specific impulse is going to increase. Okay, theoretical question. Similarly, look at the another question asked for the rocket motor. It is asking like this: a rocket with an initial mass 10,000 kg, initial mass let it be m naught, 10,000 kilograms, ejecting mass at a constant rate of the amount of fuel burning or amount of material leaving per second is given 100 kilograms per second, and at constant velocity throughout the nozzle, what should be the exit jet velocity so as to increase the velocity of the rocket by 2 kilometers per second. The increase in velocity of the rocket delta V 2 kilometer per second I can write as 2000 meter per second, 2000 meter per second, and the time taken for gaining that change in velocity 50 seconds, time required equal to 50 seconds. Assume no drag and optimal expansion in the nozzle. Given condition is e power it is given e power 0.693 is equal to 2. It can be also written as 0.693 is equal to natural log 2. That means wherever the natural log 2 is there, in the place of natural log you can place the 0.693. Anyhow, you are asked to decide the exhaust velocity. For that there is a formula. First let us decide the final mass of the rocket. Final mass of the rocket equal to initial mass of the rocket minus the mass of the propellant leaving from the system, that is equal to mass of the fuel burning multiplied by the time taken. It is equal to m naught 10,000 minus mass of the 10,000 minus mass of the fuel burning 100 multiplied by time taken is 50. So it is giving 10,000 minus 5,000 is equal to 5,000 kgs. That is the final mass of the system. Then, as we all know, the change in velocity of the rocket equal to exhaust velocity of the rocket into ln initial mass of the rocket dividing by final mass of the rocket. The change in velocity of the rocket is given 2000 meters per second because it is given 2 kilometer per second. Somewhere it is given 2 kilometer per second. The 2 kilometer per second equal to 2000 meter per second. 2000 equal to exhaust velocity into ln. The initial mass is 10,000 dividing by the final mass. This is the mass of the fuel burning per second. This is the final mass of the rocket equal to 5,000 dividing by 5,000. Right, 2000 is equal to exhaust velocity into ln 10,000 by 5,000 2 ln2. In place of ln2 you can write 0.693. 2000 is equal to exhaust velocity into 0.693. Therefore, exhaust velocity equal to 2000 dividing by 0.693. You simplify this value for getting the answer 2886 meter per second. That is the exhaust velocity of the gas from the nozzle. Understood clearly? Yes. It is a quite lengthy problem, but easy only. Similarly, look at the another problem. A heat engine is supplied with 250 kilojoules of heat at constant fixed temperature of 227 degrees centigrade. The heat supplied to the heat engine Q1 is given 250 kilojoules per second at a maximum temperature, maximum fixed temperature given 227 plus 273. For getting in Kelvin, it is giving 500 Kelvin. The heat is rejected at 27 degrees centigrade. The temperature where the heat rejection is happening at 27 degrees centigrade, 27 plus 273 gives 300 Kelvin. And the cycle is reversible, right? Cycle is reversible. What is the amount of heat rejected? Very simple question. For any reversible cycle, Q1 by T1 is equal to Q2 by T2. Very simple question. From this Q2 equal to Q1 by T1 into T2. Look at the Q1 250 dividing by T1 500 into T2 300. Here it is 2 times 300 by 2 150 kilojoules per second. That is the amount of heat rejection. Very simple question. 150 kilojoules per second. Option D is absolutely correct. Very simple question. Similarly, look at another question, theoretical question. Which of the following equations describes the behavior of a thermodynamic system undergoing phase change, right? Phase change process or phase transmission. Class is what class is Kepler equation? Van der Waals equation. Van der Waals equation is for real gas. Next, Maxwell-Boltzmann distribution, Gibbs-Duhem equation. You know the Clausius-Clapeyron equation dP by dt in the saturation region is equal to H of G dividing by T sat, saturation temperature multiplied by specific volume of the saturated vapor minus specific volume of the saturated liquid. So, this is the Clausius-Clapeyron equation is used for finding the latent heat during the phase change process. Anyhow, it is given for phase change process. Phase transmission means phase change process. For the phase change process, you can use the Clausius-Clapeyron equation for finding the latent heat. Option A is absolutely correct. Okay. Similarly, look at another question, right? Asking very simple question. A Carnot engine receives heat at 400 Kelvin. Heat receiving temperature for the Carnot cycle is 400 Kelvin. Has an efficiency 25%. Efficiency of the Carnot cycle equal to 0.25. What is the COP of Carnot refrigerator working between the same temperature limits? Wherever the or whenever the heat engine, heat pump and refrigerator are working for the same temperature limits, relation between the three is efficiency of the heat engine equal to 1 by, otherwise I can also write like this, it can be also written like this, very simple. The COP of the heat pump equal to 1 plus COP of the refrigerator for the same temperature limits. Remember, this rule is valid as long as the heat pump and refrigerator both are working for same temperature. It is equal to efficiency of the heat engine. Therefore, 1 plus COP of the refrigerator is equal to 1 by efficiency of the heat engine. Look at the heat engine efficiency, that is Carnot cycle efficiency 0.5, 1 by 0.25, 1 by 0.25 equal to 4. That means 1 plus COP of the refrigerator is equal to 4. Then what is the COP of refrigerator? COP of refrigerator equal to 3. That is the answer. Look at the option C. Option C is absolutely correct. Okay. So with this, thermal part is completing. Next part, aptitude, Mr. Rajesh sir will take it. Okay. Thank you.
Good evening everyone, my dear friends. In our ISRO examination, total we are facing the 15 questions, 1 question mathematics, okay, remaining 14 questions. Okay, look at here. These questions, my dear friends, very easy, easily are getting actually. Look at friends, all of you. Andre and Batty together weight 150 pounds, Batty and Christian, simply you can observe A, B, C, D point of view. Okay, so the given we are getting equations. Based on the equation, you are calculating the David weight. Okay, we need David weight. So David weight, substitute in the equations, you are getting the answer D, option D, 210. Next, some books are tables. Okay, some books are tables. Some books are tables. Some books tables. Some tables mirror. Some tables mirror. This is one type of diagram. Here books mirror relation not given, maybe like this also. Okay, maybe like this also. So we are not giving the conclusion. Okay, we need a perfect information, that is a conclusion. So we are not getting we don't have a confirmation. But according to the option, neither are not available. When contradiction is there, then option is going to the either or, 1 or 2 relation. So what is the conclusion? Some mirrors are books, some mirror book. No book is a mirror. Out of the one, guarantee possible. That's why either or. In case neither nor is there, priority neither nor, but neither nor not available. That's why C is the right answer. One contradiction is there, then option C is the either or right answer. Next, you can observe this figure. Okay, this one now only switches right to left to right to left to right to left only. Okay, right, left. So right. Okay, here right, left, again right. So same here right, left, right. Here left important. Here left important means option C is the possible. Option C is the possible, and dot anti-clockwise direction. Okay, anti-clockwise direction. You can observe carefully. Option C is the right answer. Next, shaded. Okay, again shaded. So I want again shaded important. So 103 shaded important. 103, 103. So B and D wrong. Okay, shaded. Next shaded important, and 3 lines important. 3 also. Okay, shaded part. So C is the answer. 1, 2, 3. Here the shaded is there, so wrong friends. A is the right answer. Sorry. Next, based on the pattern, observe this dot position 1, 2, 3. Okay, 1, 2, 3. So 1, 2, 3 important. Last place, okay, last place in the middle. This one middle, this one middle. About the star 1, 2, 3. Okay, observe 1, 2. Next 1, 2. Okay, observe the star place also. Okay, observe the star place also. 1, 2, next step 3. So B is the right answer. Next, a mixture of the 45 letters. You can use the concept. First 1:2, next it become 2:1. Simply meaning 1:2, 2:1 means simply it is double actually. Okay, so just for convenience, 45 1:2. So 15 and 30. Only this one added, this one fixed, this one fixed. So 2:1 requirement. This one fixed means left and right side multiplication with 30, left side also multiplication 30. 32s are 60. So this is 30, 30, 30 as it is. So 15 is 60. So how many letters added? 45 letters. If you added 45 letters, the final result output is a 2:1. So answer 45. B is the right answer. Next. So 2 to 8 floors. Okay, second floor do not have a lift. Second floors do not have a lift. We are not giving the conclusion for this question. Seventh floor means mentioned means compulsory we had a lift. So clearly right. Only floors above the third floor have a lift. If in case we have a lift, it is existing for every floor also. But not only mentioned only floor above the third floor, wrong. All floors may be reached by the lift. Suppose the building had only 2 shifts, only 2, okay, only 2 floors, then no lift. So we can't give complete confirmation. Okay, 100% is not given. That's why 100% is right is only this one only, B. Next, a cube has volume 8. Volume 8 means 2 cube. So that is 8. Everything is a double. So double means 4. Then answer 4 cube. 64 is the answer. Okay, my dear friends. Next, you can simplify this equation. Okay, based on the calendar concept, you can simplify. You are getting the answer Sunday. Okay, so 28 means 0 odd days. May, January 3, February 0, March 3, April 2, 2000 0, 5 plus 1. So 6, 12, 14 odd days. 14 divided by 0, 7, again 0 odd days means Sunday is the answer. Okay, my dear friends. Next, Jessica has 4 children. Jessica has 4 children. Two of the children have a blue eyes, two of the children have a brown eyes. Two of them blue eyes, two of them brown eyes. Which 2 persons we don't know. Okay, which 2 persons we don't know. Half of the children are girls. Half of the children are girls means Jessica has 4 children. Half means 2 girls, pakka girls. So what is the confirmation? At least one girl has blue eye. We can't decide. 2 of the children are boys, obviously right. Okay, this is one also, maybe or may not. So only 2 is the right answer. Right, my dear friends? Next, this is mirror image. Mirror image means left become right, right become left. So here right is a 2. So start with the 2. So what is the possible option? B is the possible option. Next, football 50, cricket 40, basket 30. Basket 30. Okay. So 4 plus 5 plus 4, 12, 26. This one 24. Okay. Next, cricket 40, 14, 28. Okay, 12. Then what is the question? Then what is the number of players? What is the number of players who play football or cricket or but not basket? Okay, football and cricket but not basket. Okay, football, cricket but not basket. Okay, but not basket. So then answer this one added. So answer should be 26 to 24. Answer is 50. Next, no women can teach. No women teacher can play. This is woman teacher. Play completely separate. Some women teachers are play athletes. Okay, women teachers play athletes. Male athlete, male terminology not given. How can you decide? So no. Okay. Some athletes can play. Some athlete to play, relation not given. How can we decide? We don't know. Conclusion is pakka information. So we don't know. Okay. Neither nor. Option is there? Yes. So D is the right answer. Next, you can observe friends. Here by using this one, 3 into 2 minus 1, 5 into 2 minus 2, 8 into 2 minus 3. Okay. Next, 13 into 2, 26 minus 4, 22. 22 into 2, 44 minus 5. That is 39 is the answer. Okay, my dear friends. These are the questions from the aptitude, my dear friends. Okay, briefly I given the key. Okay. In future, I mean, in coming as early as possible, in complete detail. Thank you.
Hello everyone. So let us discuss. There were 3 questions from the compressible fluid flow. Actually 2 questions from the compressible fluid flow and 1 question on the thermodynamic relation, right? That is intensive and extensive property. In that, how to check intensive and extensive, that change, how to find change if it is variable of 2 parameters, that we have discussed, right? Okay, let us discuss these questions. See, in your set C, question number 22 was an air flow with Mach number of 2. Here Mach number is given. Mach number is given 2. Okay, passes through a normal shock. The shock is normal shock, right? If the ratio of specific heats, that for air, yes, we know that air is a diatomic gas, so gamma is 1.4. Then the shock strength is, they are asking shock strength. See, you might be knowing that shock strength is pressure difference P2 minus P1 divided by P1. This is a shock strength. Let us divide separately by P1, right? So it will be P2 divided by P1 minus 1. P2 divided by P1 minus 1 and P2 divided by P1. This ratio for normal shock, we know. This formula we have derived, right? So this shock strength becomes, see, what is P2 by P1? It is 1 plus gamma minus 1 divided by 2 Mach number square, yes or no, power gamma divided by gamma minus 1. This was the formula, right? But there is minus 1 also, right? Minus 1 also. And if you simplify this equation in notebook as it is, you will find, if you simplify this equation this shock strength becomes 2 gamma divided by gamma plus 1 into Mach number square minus 1. This formula you will find, and this will give easily answer, right? So let us find. So 2 into gamma is 1.4 divided by 1.4 plus 1 into Mach number is given 2 square minus 1, right? 2 into 1.4, it is 2.8 divided by 1, this is 2.4 into 4 minus 1, 3, right? See, now 28 by 24, 3 by 24 is 8, 28 by 8. 28 by 8 is 3.5. Simple calculation now. Simple calculation. So shock strength will be here. In this question, we can say shock strength is 3.5. Option B was correct answer for this question. Right. Let us check the next question. A weather balloon, we have one balloon, okay, is rising vertically in an atmosphere. It is rising vertically, okay. Temperature T at any point depends on both time T and altitude h. See, here temperature is a function of time T and altitude h. Okay, sir. Then the balloon rises with a vertical velocity of 10 meter per second. Vertical velocity. Here vertical velocity, how can we write? Vertical velocity is dh by dt. So this vertical velocity is given 10 meter per second. Yes, sir. Then okay, for a given time, the change in temperature with respect to altitude is, for given time, the change in temperature with altitude dou T by dou H is how much? Minus 0.01 degree Celsius per meter. Okay, sir. Then similarly for a given altitude, the change in temperature with respect to time, that is change in temperature with respect to time, partial change is given. It is minus 0.01 degree Celsius per second. Yes, sir, degree Celsius per second. The total change in temperature dt by dt experienced by the balloon is, they are asking total change in temperature. See, here we know that temperature is function of time and h. And in mathematics we have one theorem. How to write this? See, if temperature is a function of time and h, then change in temperature we can write this change in temperature with respect to time into dt plus change in temperature with respect to height into dh. This is a partial change. Yes, sir. So let us divide both sides by dt. So small dt, time. So dt by small dt is equal to dou t by dou t, dt by dt will cancel, plus dou t by dou h into dh by dt. This dh by dt is velocity already given in the question. Okay, so this is the question. So is equal to change in temperature with respect to time. It is given minus 0.1. It is minus 0.1. Yes. Yes, yes, yes. Minus 0.1. Yes, sir. Minus 0.1. So it is minus 0.1. Yes or no? Okay. Minus 0.1 plus. This is given minus 0.01 minus 0.01 into velocity is given 10. Velocity is given 10. If you solve this dt by dt, change in temperature with respect to time, you will find minus 0.2 temperature in degree Celsius, time in second. So minus 0.2 is your correct answer. So if you check here, minus 0.2, A is your correct answer. For this question, option A will be the correct choice. Right. Let us check the next question. See, again similar type of question. First question was similar type of this. That is question number 22. See, in an isentropic flow, formula is same only. In an isentropic flow, okay, with a stagnation pressure is given P naught is equal to 6 megapascal. Yes, sir. Then find the static pressure. They are asking what is static pressure P. Static pressure. Find the static pressure, right, at the point where flow is sonic. Flow is sonic. What is the meaning of sonic flow? Mach number is equal to 1. Mach number is equal to 1. Yes. And gamma value is given 1.4. Yes. Adiabatic index. Ratio of Cp and Cv is 1.4. Consider 1.2 power 7 is equal to, okay, I will use this relation because as calculator was not permitted, we will use this relation. Options are right. See, we know that here, we know that P naught by P, stagnation pressure by static pressure, is equal to 1 plus gamma minus 1 divided by 2 into Mach number square power gamma divided by gamma minus 1. Yes, this is the formula. So let us put the values. So P naught by P is equal to 1 plus gamma value is 1.4 minus 1 divided by 2. Mach number is 1 square into 1.4 divided by 1.4 minus 1. Let us resolve. Very simple calculation. Let us resolve. See, 1.4 minus 1, 0.4 divided by 2. 0.4 divided by 2 is 0.2. 0.2 plus 1, 1.2. This is 1.2 into 1 is 1. Right. Power. 1.4 divided by 0.4. 1.4 divided by 0.4. See, can I say this? 14 by 4. 14 by 4 is how much? 7 by 2. Yes, sir. So it is 1.2 power 7 by 2. And in question, this value 1.2 power 7 is given. 1.2 power 7 is given. Right. So this P naught by P is equal to 1.2 power 7 is how much? Let us replace this. 1.89 power 2 divided by 2 is there. 1.2 power 7 is given. Okay, this power will go. It is 1.89. 1.89. So P we need to find. So P is equal to P naught divided by 1.89. P naught is 6 divided by 1.89. No need to solve. As this number 1.89 is less than 2, the ratio is more than 3. This ratio is more than 3. As this number is less than 2, ratio is more than 3. And if you check the options, more than 3 is only one option we have. That is option B is correct choice. Okay, that is it.
Right. So, let us solve the questions of production. So, in this question what they said is the power required for turning operation right. Let us start production related questions. In this they said the power required for turning operation is measured as a 2.5 kilowatt. If the cutting force is 800 Newton and the cutting speed is 90 meter per minute, calculate the mechanical efficiency. Those who are aware about mechanical efficiency calculation from the thermal sciences, they also easily able to calculate this question, where mechanical efficiency is nothing but output to input, whereas input is a 2500 watt, because 2.5 kilowatt is power required, whereas cutting force is 800 and cutting speed is 90, but it is given as meter per minute. So, if I am writing seconds, so it will be like by 60 if you do, then simplify this, you will be getting a 48%. So, the task of percentage calculation you need to perform to get the answer for this question. The answer is option D. Next, Solvent's hypothesis relates between, it is actually the hypothesis based on this we used to make calculation of the surface finish and also cutting forces. So, it is cutting forces and surface finish. Machinability index of SAE 1112 steel. Basically, SAE 1112 steel, from material science point of view, we used to study that it is called as a free cutting steel, right. Free cutting steel is that particular workpiece material. It will become always reference in the calculation of machinability index. So, when you observe machinability index, it is nothing but Vt by Vs into 100 we used to write, whereas they are talking about Vt, which is also SAE 1112, whereas Vs is a standard workpiece. This is also actually a free cutting steel only. So, when both cutting speeds of test specimen and the standard specimens are of same material, when they are asking its machinability index is always going to be a 100%. So, it will be a reference machinability index. Based on that only we used to make a comparison of all the workpiece machinability indexes. So, for this answer is 100%. Next, in this question, face milling with a cutter of 100 mm diameter. So, diameter is equal to 100 mm and the cutting speed V is given as 1 meter per second. If the cutting speed is 1 meter per second, what should be the spindle speed? So, cutter diameter and speed is available, rotational speed they are asking, n is equal to 1000 V by pi into d, but if you observe here it meter per second, therefore, it is even by 60. So, if you are simplifying this, it will be like 6000 into 1 by pi into 100. So, it will be like 600 by pi you will get, right. 60,000, no, yeah, 600 by pi. So, pi again you can write as 600 by 22 by 7. So, 7 if you take on the numerator and simplify this value. So, you will end up with answer as 190, or else you can write it as 4200 by 22. So, 22 ones are 22 nines is almost close to 200. So, 198, based on that you can say it is 190. So, spindle speed is 190 RPM. So, that is this question. Next, it's a metrology question where H7 G6 fit is given, symbol H7 represent copied question from the previous gate papers only. So, H7 is the designation based for any basic size, the tolerance zone position of a hole. For that IT7 is a grade of tolerance. So, capital H is the hole tolerance zone that is lying on the basic size. So, hole tolerance zone starting at the basic size, it start at the basic size, lying on the basic size or starting at the basic size. So, the answer is option C. Next, in this question they are asking basically metrology question, linear measuring scale has a known systematic error. So, systematic error is given as plus 0.05 mm. For every 100 mm of measurement, if the scale is used to measure a distance and reading obtained is 5 meters, so what will be the actual length of the distance they are asking. So, basically in this question while solving, systematic error is given as a plus 0.05, whereas for 1 meter, which is nothing but 1000 mm, this particular value is a systematic error. Then for 5 meter, nothing but for 500 mm, 5000 mm, which is actual measurement value, what will be the actual length we need to calculate. So, for that actual length is actually equal to, actual length will be equal to measured distance minus total error, right. Whereas in this, if you look at that given data, 5 meter is the total distance given. So, actual length based, if you are calculating this, you will be getting a 0.05 by for 1000 mm. This will be the error versus measurement distance. So, that will be total error by total distance is equal to 5000. So, based on this you will be getting total error as a, decimals are there, very simply you can calculate this value. So, you will be getting this total error as 2.5. So, 2.5 mm from the 5000, if you subtract, you will be getting the actual length, which is 4997.5 mm. So, this will be the answer. So, basically you are trying to calculate the difference between a measured distance and the total error that is giving you actual length of the workpiece. So, simple calculation, just you need to go with the numbers without making any mistake on the decimals will give you the proper answer. Whereas, next this question, very interesting question. In this what they said is useful tool life of the HSS tool machining a mild steel at 18 meter per minute is 3 hours. Be careful, 3 hours is given. So, when cutting velocity is equal to 18 meter per minute, the tool life corresponding to that is equal to 3 hours is 180 minute you will be writing. Many used to make a mistakes here because they are asking at the end answer is in minutes. Calculate the tool life when the tool operates at cutting speed of cutting velocity is equal to 24 meter per minute. So, at this they are asking what is T2, assuming n which is exponent as 0.125. Therefore, Taylor's tool life equation, if you are writing V1 T1 power, directly I am writing V1 T1 is equal to 180 power point V1 T1 power ఏమైందబ్బా ఆపినా to here, right. So, in this question, as we reached like if you are applying a Taylor's two-life equation, V1 T1 power 0.125 is equal to V2 T2 power 0.125. So, they are asking what is T2. So, percentage based calculations also you can do, or else like 18 by 24 into 180, but this power 1.125 if you bring on the left side, it will be 1 by 0.125, it will be 8. So, 3 by 4 will be 0.75 power 8 into 180, or else by using your aptitude reasoning you can go for the percentage calculation. You will be getting like 0.75 power 8 will be almost approximately 0.1, multiplying 180 will be giving you 18 minute. So, answer is 18 minute, but probably in a examination hall you may not able to recollect, then without calculator it is difficult, but those who are having a proper aptitude approach easily they able to approach this answer. But for that percentage calculations of your reasoning aptitude is required. Whereas least count they are asking a least count of micrometer with a pitch of 0.5 mm and the thimble having a 50 divisions. So, in this case 50 division based they are asking a least count. So, least count calculation will be like printing mistake unnai. Right. So, least count will be like pitch of the given screw thread is 0.5 mm and thimble having 50 divisions is given. So, based on this answer will be 0.01 mm. Answer is option A, right. That is it.
Let us start the questions on the subject of fluid mechanics. Let me start with the first question. For solid sphere falling vertically downward under gravity in a viscous fluid, terminal velocity V varies according to what proportionality with diameter. Terminal velocity formula is 1 by 18 mu density of sphere minus density of fluid into GD square. So, velocity is proportional to d square. Option B will be correct. Moving further. Consider following statements pertaining to boundary layer on flat plate. The first statement is thickness of laminar boundary layer is proportional to x power half. This is a correct statement. Next question is thickness of turbulent boundary layer from leading edge is proportional to x power 4 by 5. This is also correct. Next is the boundary layer is laminar when Reynolds number is less than or equal to 5 into 10 power 5. This is also correct. So all three statements are correct. Therefore, option A would be correct. Moving further. This is a question on basic hydraulic press. The question is saying it is having a ram of 30 centimeter diameter and plunger of 4.5 centimeter diameter. Find the weight lifted by the hydraulic press when the force applied is equal to 500 Newton. So we can use the equation pressure here and pressure here, both of them are same. So force divided by pi by 4 times 4.5 square. So I am writing straight away 4.5 square because pi by 4 will get cancelled off now, is equal to W divided by 30 square. So if you put in the value of F as 500, push this 30 over here, the value of W will come out to be 22.22 kilonewton. The answer is 22.22 kilonewton. If you see, option D would be correct. Option D would be correct over here. Moving further, the question is saying a sphere is moving in water with a velocity of 1.6 meter per second. Another sphere of twice the diameter is placed in wind tunnel. It is 750 times less dense and 60 times less viscous than water. The velocity of A that will give similar dynamic condition is what? Over here we have to apply dynamic similarity using Reynolds number for model has to be equal to Reynolds number for prototype. Mind you, air flow over here is model flow and water flow over here is prototype flow. Water over here is prototype flow. Okay. So I need to identify the velocity in air. So let me write over here rho into V into D by mu for air is equal to rho into V into D by mu for water. Given to me the value of velocity of water, density ratio, diameter ratio, viscosity ratio is given. So I can write velocity in air has to be equal to velocity in water multiplied to density water by density air multiplied to diameter water by diameter air multiplied to viscosity air by viscosity water. Now it is given to you the velocity in water is 1.6. So let us put in the value over here 1.6. Density water by density air is equal to 750 according to question. Now he is saying that the diameter placed in the wind tunnel is twice that in water. So this is 1 by 2 and this over here is 1 by 60. Should you put in these numbers, you are going to get the answer over here as 10 meter per second. The answer you should be getting over here is 10 meter per second. Option B would be the correct answer over here. Moving further, this question is from kinematics. The question is saying two-dimensional steady incompressible rotational flow is there. Stream function is given by psi over here is equal to x square minus y square. The corresponding phi value will be equal to how much? This question has appeared in every examination as such. Very standard question. The answer will be 2xy plus constant. Anyway, how do you obtain this thing? You will develop the value of u from here. The value of u is equal to, let us say, dou psi by dou y minus of, which is equal to how much? It is equal to 2y. And this is also equal to dou phi by dou x. So from here you will get the value of phi is equal to 2xy plus, let us say, a function of y. A function of y. How to identify the function of y over here? From here again you will get the value of v. V is equal to dou psi by dou x, which is also equal to dou phi by dou y. If you put in this value, you are going to get over here, this value will be equal to 2x is equal to 2x plus f dash of y. Now from here f dash of y is equal to 0 means f of y is a constant. So I have identified this f of y is a constant in this equation. If I put f of y is a constant, I will get the answer as option B, 2xy plus constant. This is a very, very standard question. Almost every book has this particular question. Moving further. A Borden gauge connected to a closed tank indicates 40 kilopascal at a place where atmospheric pressure is 95.48 kilopascal. If the tank is carried to a higher elevation where the atmospheric pressure is 90 kilopascal, the reading in the gauge will be equal to how much? Mind you, the system over here is closed system, therefore the absolute pressure is going to remain constant. Should the absolute pressure remain constant, I can say over here P gauge plus P naught at location 1 has to be equal to P gauge plus P naught at location 2. Now if you see logically, you are seeing over here your P naught value is changing from 95.48 to 90. That means P naught has dropped by 5.48. So P gauge has to rise by 5.48. So add 5.48 to 40, you will get the answer as 45.48. There is no need to write anything further. Straight away you can mention the answer over here is option C. Moving further, the next question over here is 90% of an iceberg volume is below surface of sea water, only 10% is visible above the surface. Find the density of iceberg if the density of sea water is 1025 kg per meter cube. Again, every book you see will have this question. Probably the percentage of iceberg might be different, but the question spirit will still remain the same. How do you answer this? You can straight away go for equilibrium, write down weight of iceberg is equal to force of buoyancy. So gamma of iceberg into volume of iceberg is equal to gamma of water into volume of water. What is the volume of water over here? It is equal to 0.9, that is 90% volume of iceberg. So from here I can say volume ice cancelled off, G also cancelled off. Density of iceberg is equal to 90% of 1025. 1025. So from 1025, you just subtract over here 102.5. You should get the answer as 922.5. Answer is 92.5. You can find it as option C. Answer over here is option C. Moving further, the equation of velocity distribution over a flat plate is given by u is equal to 2y minus y square, where u is velocity in meter per second at a point y meter from the plate measured perpendicular. Assuming the value of mu is equal to 8.6 poise. Now please be careful. This is what they keep on doing. They'll mention the value of viscosity in CGS unit. You have to convert in SI units always. Anyway, the value of mu is equal to 0.84 Pascal second, 86 mind you, 0.86 Pascal second. The velocity profile is given by 2y minus y square. What is the shear stress at a distance of 15 centimeter from the boundary? You have got the value of u. What is the value of du by dy from here? It will be equal to 2 minus 2y. Put in the value of y as 0.15 meter. So 2 minus 2 times 0.15 should give you du by dy is equal to 1.7 second inverse. Now the value of shear stress by Newton's law is equal to mu du by dy. If you multiply 0.86 to 1.7, 0.86 to 1.7, logically the value should be less than 1.7, but not as less as going down to 0.24. So the only answer over here is 1.46. Without a calculator, try to make reason with the options. You don't have to get the answer, you have to choose the answer. Make use of this thing. Moving further, again a very standard question, appears in many examination, many books. The question is saying a thin plane lamina of area A and weight W slides down a fixed plane, inclined at an angle of alpha and maintains a uniform gap epsilon from the surface of the plane. The gap being filled with an oil of constant viscosity mu. Terminal velocity is equal to how much? Whenever you wish to find out terminal velocity, straight away apply equilibrium. If you should apply equilibrium, what do you have over here? This is the weight component of this particular plate, which is equal to W sine alpha, and this is a shear force which is equal to shear stress mu du by dy. Assuming since the gap is very, very small, the velocity profile is linear, so du by dy over here will be velocity divided by epsilon multiplied to area. Now equate both these things. If you want to get the value of v, you can say v has to be equal to W epsilon sine alpha, W epsilon sine alpha divided by mu times area. Look for this option, W epsilon sine alpha divided by mu area. Option B would be the correct answer. W epsilon sine alpha, right, upon mu area. This would be correct. Okay, na? I hope it is clear till here to all of you. Moving further to the next question. The question over here says, a glass tube of 90-degree bend is opened at both ends. It is inserted into a flowing stream of oil with a specific gravity of 0.9, so that one opening is directed upstream and the other is directed upward. The oil inside the tube is 50 mm higher than the surface of flowing oil. The velocity measured will be equal to how much? Ab dekhiye, this is a very simple question. He did not give you a diagram. He tried to mention the entire diagram as a statement. So he is saying you are having some flow of oil over here. Let us say this is a direction of flow. He has mentioned that he is placing a pitot tube kind of instrument over here, a pitot tube kind of instrument like this. Okay, 90-degree bend pitot tube basically. He is saying the rise in oil over here is up to a height of 50 mm. That means this 50 mm is basically your dynamic head. If it is dynamic head, the velocity has to be equal to coefficient of velocity multiplied to root over of 2g into h dynamic. Okay. Now you see, look at the options given over here. The options are 1.99, 0.99, 2.99 and 3. Guarantee these two can't be the answer, because if one of these two is answer, I am not going to solve it. Okay. 2.99 and 3, I am having a tolerance of only 0.33%. I'll avoid solving the question then. Okay. So what I'll do, I understand the answer would be either one of these. So let me take an assumption g is equal to 10 now. Should the value of g be equal to 10, what do I have over here? CV is not given, so CV is 1. 2 times 10 times height 50 mm means 0.05. Ab dekhiye 2 times 0.05 will give me 0.1. 1 times 10 gives me 1. Root 1 is equal to 1. Answer should be 1 should the value of g be equal to 10. But since 1 is not there, the best answer is 0.99, assuming g is equal to 9.81. So answer over here will be option B. Please look at options whenever you are solving questions. Options will motivate you to solve in a particular way. Okay, na? Moving further, the question, very simple question now. He is asking you, if the surface tension of water air interface is 0.073 Newton per meter, the gauge pressure inside the rain drop of 1.6 mm diameter is equal to how much? अब देखिए rain drop के लिए you are going to have the value of delta P as 4 sigma by diameter, that is equal to 4 times sigma is equal to 0.073, diameter is equal to 1.6 mm. So it is equal to 4 times 73, 4 times 73 divided by 1.6 over here. 4 times 73 would amount to 292. Up 292 divided by 1.6. Look at the options. 292 by 1.6. The reasonable answer should be option A. 182 would be the correct answer over here. 292 by 1.6. 182 Pascal would be the answer. Fine. These are the questions from fluid mechanics. I am assuming these questions were clear to all of you. I will hand over to the next faculty to take the next subject. Thank you.
So here we have a few questions related to material science. Let's see those are right. So if you see the fifth question, so this question is basically related to what the cold working case, right? So what is the primary mechanism responsible for the increase of the strength and hardness during the cold working of metals? So as we know that, so the cold working takes place below the recrystallization temperature, right? So that is approximately below 0.3 times of the melting point temperature, right? So here, so in order to increase the strength and hardness, the main the cause I can say that to increase the dislocation density and the entanglement hindering dislocation movement I can say, right? So that will be going to occurs in the material. So that with that causes the increase in the strength and hardness. So option B is the correct one, right? So the same solution is given here. And as we move to the next one, we have in a metal diffusion bonding, which are the process variables. So to form any diffusion bonding, we have a main 3 parameters are there. Those are the pressure and the temperature and the time. So the correct option concerned to this question is option C, right? So each parameter having the its own unique feature I can say. So whenever we consider the pressure, so which will make the contact between the 2 surfaces, as well as the temperature causes to hit the base contact surfaces I can say, right? So with that the bonding will be going to take place with the help of the pressure, and the parameter one more we have the time, right? So as we move to the next one, we have so which of the following properties of the metal that or cannot significantly change it by the heat treatment process, right? So here only the one parameter it will not be going to affect, that is elastic modulus I can say, right? That is elastic modulus. And because it is because it is mainly dependent on intrinsic atomic structure as well as the bonding of the metal, right? So that's why option C is the correct I can say, right? So as we move to the next one, we have the composite related small numerical question I can say. So the composite material consisting of 60% by volume of fiber that is given along with the respective modulus is given, that is 200 GPa, as well as you concern to the matrix it is given. So we need to find out the modulus of the complete composite, right? So by using the rule of mixture I can say, right? So as we know that here the basic formula concerned to the this one rule of as per mixture I can say, that is concerned to the composite, which is equals to Vf, that is modulus of respective fiber as well as the volume I can say, plus modulus of the matrix as well as the volume percentage, right? So which gives us 200 into 0.6, right, plus and modulus of this one matrix I can say, that is 5 GPa, right, into 0.4 percentage, that is percentage is given 40%, right? So from this we can conclude that 122 GPa, right? So concerned to this one, we have a answer option A is the right answer, right? By using the rule of mixtures we can find out, right? So further, if we move on to the next question, we have a metal has a yield strength of 300 MPa as well as the fracture strain is given 0.2. So here by considering the linear elastic behavior, right? So we need to find out the approximate toughness I can say, right? So here concerned to the data we have, right? So from this stress strain diagram concerned to the ideal case, so we can calculate the area I can say, that is toughness area, that is half into base into H I can say, right? So similarly, so the ultimate toughness I can say, right? So the toughness we can find out half into, that is yield strength is given I can say already in the data, so which is 300 MPa into fracture strain is given, that is 0.2, right? Through this we can calculate the answer as a 30 MPa, right? So the correct answer considered this one we have option B, right? So and the next question we have, So which is basically related to the mechatronics, I can say. So which is the topic concerned to the actuators, right? So the question says that which of the following actuators is most suitable for the simple application, that is a binary on off mode, I can say. So for that one we need to choose the correct actuator, right? So concerned with this question, we have the answer is a solenoid actuator. So which is basically used to for simple operations such as the on off conditions, right? So the same animation we can see here, when the current flows through the respective circuit, the current develops the magnetic field. With that we can make the actuations to the mechanical elements through which we can make the on off conditions, right? So the correct answer concerned to this question, we have option B. So these are the questions concerned to the material science, right? Thank you.
Now let's discuss IM war questions. So the first question is this: if the selling price is rupees 300 per unit, variable cost is 200 per unit, and fixed cost is rupees 50,000, what is the break even quantity? This is very simple question, dear students. So what we need to do is, so break even quantity he is asking, so let us take it as Q. So this is fixed cost by selling price minus variable cost. So fixed cost is 50,000 divided by selling price is 300 per unit minus 200, this is variable cost. So you will get 500 units as the answer. So option D will be correct for this particular question. Okay. Now let's go to the next question. See, a machine is purchased at a cost of rupees 11,000. So the initial cost of the machine is 11,000. The assumed useful life is 9 years. So useful life of this machine is 9 years and the salvage value is 2,000 rupees. Based on the sum of the digits method, the depreciation for the 5th year would be rupees. So for this, first of all, we need to find out the total number of years. So n into n plus 1 by 2. So this will be 9 into 9 plus 1 by 2. So you will get this as 45. Okay. So you got this value as 45. Okay. So this is the total sum of years, SOY you can consider. Now we need to calculate the depreciation year wise. So for that, let us take the table like this: year and the depreciation. So at the beginning there will be no depreciation. In the first year, what we need to do is, we need to take the depreciation multiplier multiplied by, so the initial cost of this one, so P minus the salvage value SV. So this is the formula what we have to use in order to calculate depreciation year by year. So for that, 9 by 45 you need to take, multiplied by the principal is 11,000. So, at the beginning minus 2,000. So, you will get in the first year 1800 as the depreciation value. So, similarly second year, so you will take 8 by 45 into 11,000 minus 2,000. So, this will be 1600. So, the next one you will take 7 by 45 into 9,000, you will get 1400 rupees as the depreciation in the third year. So, fourth year you will take 6 by 45 into 9,000. So, this will be 1200, and fifth year, so here you will take 5 by 45 into 9,000. So, here the depreciation will be 1000 rupees at the end of fifth year. So, the correct option for this particular question will be option C here. Okay. Now, let us go for the next question here. This is very simple question, dear students. In a small engineering project, 3 time estimates of PERT activity are given. So, optimistic time. So, you all know about optimistic time. T naught is given as 8 minutes, most likely time Tm is given as 10 minutes, and pessimistic time Tp is given as 14 minutes. So, now he is asking us to determine the expected time. The formula is very simple. Te is equal to T naught plus 4 Tm plus Tp by 6. So, from this 8 plus 4 into 10 plus 14 by 6. So, approximately you will get 10.33 minutes. So, the correct answer for this particular question will be option B. Okay. Now, let us see the mathematics question. Only one question was asked, so that is related to probability here. So, which of the following mentioned standard probability density functions is applicable to discrete random variables? So, option A Gaussian distribution, option B Poisson distribution, option C Rayleigh distribution, option D exponential distribution. See, the answer for this particular question will be Poisson distribution. Okay? Thank you.
Dear students, welcome. Now we will see the questions from the topic theory of machines and vibrations. So, here we go with the first question. A cantilever beam of negligible mass has a mass m at the free end
if the length of the cantilever is halved, what is the, by what factor the natural frequency is increased? So here, as we know, the natural frequency is expressed as root over stiffness by mass. So cantilever beam carrying a point load at the free end, so the stiffness is given by K equivalent is equal to 3 EI by L cube. Okay, so now if we reduce the stiffness, if we reduce the length by half, then the stiffness is increased by 8 times, because Ke is inversely proportional to L power 3. Okay, so if we increase the stiffness, if we are reducing this by 2 times, so by 8 times the stiffness will be increased. So equivalent stiffness will be, modified stiffness will be 88 times of equivalent stiffness, and once we substitute here, so the new natural frequency we will be getting it as root 8 times of K by M, which is also equal to 2 root 2 times of initial frequency. So option D is the answer for this question. Okay, moving to next one. So here in this question they have asked about the mobility or the degrees of freedom. So here the condition given is rolling without slipping. So if a joint or a higher pair is formed which is permitting rolling motion without slipping, then it is capable of arresting 2 degrees of freedom within a plane. So degrees of freedom formula, here it is going to have a small change in it, that is 3n minus 1 minus 2j minus 2h it becomes. If it is rolling and slipping, if both are permitted, then this 2h will be replaced by 1h only. So here the number of links you can identify, that is fixed link, link number 1, this is link number 2, 3 and 4. So this is 3 into 4 minus 1 minus 2 into the number of lower pairs, that's 1, 2 and 3, 3 lower pairs and 1 higher pair. Okay, so that is 2 times of 1, which is equal to 9 minus 6 minus 2, which is equal to 1. So degree of freedom here is option B is the answer. And if we consider rolling plus slipping, then here replacing h, 2h with h, we get the answer as option 2. Okay, option C would be the answer in case of rolling with slipping. Now moving to next question, the inversion of the mechanism is obtained by. So this is a straightforward fact checking. So here in the first option says that changing a higher pair to lower pair. No, that is an equivalence condition. Second option it says obtained by fixing the different links in a kinematic chain. So C, option B is more relevant. Next is turning it upside down. This is not correct. Option D says that obtained by reversing the input and output motion. No. Okay, so as per the question, the option B is the answer. We will be changing the fixture for the adjacent links in order to obtain the inversion. Moving to next question, in the statement an eccentric mass rotating at 300 rpm will create x times more unbalanced force than 50% of the same mass rotating at 300 rpm. So there is a mass m which is rotating at 300 rpm, m into 300 whole square at some radius. This is equal to x times the another force which is having 50% of the mass, that is m by 2, and that is rotated at the same radius, and the speed is reduced to 300 square. Okay, so if we equate these two and solve for x, then here we get x is equal to 200. The factor is 200 because upon equating, so this becomes 100, ratio of 3000 square by 300 square is 10 square, that's 100, 100 into 2 is 200. Okay, so option D is the answer for this question. Moving to next question, for a gear pair the center distance is 200 mm, so CD is equal to 200 mm and the module is 5 mm. So the summation of teeth on the gear pair is dash. So center distance is equal to module into teeth on pinion plus teeth on gear divided by 2, and that is, we need to find the summation of both the teeth. So CD here is 200 into 2, module is 5, that's equal to Z1 plus Z2. So that's 400 by 5, which is equal to 80. So option B is the answer for this question. Sorry, option B it has to be. Okay, moving to next question. A mass of 10 kg is attached at the end of spring with a stiffness of 0.49 Newton per mm. The critical damping coefficient for the system is, critical damping is given by C subscript C is equal to 2 root times of mk. So 2 into mass is given as mass is 10 kg and the stiffness is 0.49 Newton per mm. So 0.49, if we convert that into meters, then we should multiply with 10 power, we should divide by 10 power minus 3, which is multiplication with 10 power 3. So this comes out to be as root of 10 power 4 is 10 square and 0.49 under root is 0.7, and this is equal to 70 Newton second per meter. That's option B is the answer. Okay, option B is the answer. Next is, in the vibration isolation system, the transmissibility will be less than unity for the damping factors if the ratio of forcing frequency to natural frequency is dash. So here if R is almost equal to 0 or closer to 0, that is ratio of excitation frequency to natural frequency, if it is very much closer to 0 or very smaller in value, then epsilon is equal to 1. And if R is less than 1 to R equal to root 2, then epsilon is greater than 1. So this zone we refer as magnification zone, wherein transmissibility ratio is more, and from at R equal to root 2, okay, so this has to be R less than or equal to root 2, less than or equal to root 2 in this range. So when R is equal to root 2, epsilon is equal to 1, and if R is greater than root 2, epsilon is less than 1, and if R approaches to infinity, epsilon approaches to 0. These are the conditions you need to remember. So here what has been asked, the transmissibility ratio will be less than unity for all the values of damping if the ratio of forcing frequency to natural frequency is more than root 2. It is more than root 2. That is option C is the answer for this question. Okay. So if it is less than root 2, then epsilon value is greater than 1. Okay. Moving to next question. In a multi-rotor system, the torsional vibration, the maximum number of nodes that can occur. So here we need to recall a standard empirical relation, that is the number of nodes is equal to number of rotors minus 1. So option D is the answer, that is equal to number of rotors minus 1. Straightforward formula. Next is, how many icenters does the given mechanism possess? So here in this configuration diagram, so you are more likely to commit a mistake over here. So let's do the link counting. This is link number 1, 2, this is link number 3, and this is whole link number 4, and this is link number 5, and this would be link number 6. So here you find the appearance of this joint little different. So you are finding a tilt or some slotted portion is there, which is going to have the angular motion. So this will be link number 6 and this will be link number 1. Okay. So how many icenters are there? So number of icenters over here can be computed by, that is n into n minus 1 by 2, which is equal to 6 into 6 minus 1 by 2, which is 30 by 2, which is 15. So option B is the answer. Next, the planar mechanism has got 8 links and 10 rotary joints. Using the Grubler's criteria, the number of degrees of freedom is equal to dash. So Grubler's equation, we know it. It's a standard formula, that is 3n minus 1 minus 2j. Higher pair is not included. So 3 into 10 minus, number of links is 8, 3 into 8 minus 1 minus 2 into 10. So this is 21 minus 20, which is equal to 1. It's a completely constrained mechanism. So for this question, option B is the answer. Okay. Next one, a multi-body dynamics simulation. Which of the following typically is not considered as a rigid body parameter? So here, dear students, you should be very careful about a keyword which is not relevant or which is a differentiating from the other of the options. So here mass is there, inertia tensor. Inertia tensor is once again relevant to the mass. Okay. Next is center of gravity. Center of gravity is also related with the location of the mass. okay, and the damping coefficient is an option which is irrelevant. So option C has to be the answer, straightforward. Without any, without without thinking, directly we can approach to the option C just by checking the relevance. Okay, so option C is the answer. That's all the questions from the theory of machines. Dear students, let's see the questions from the another topic called as machine design. So here is the first question. A closed coil helical compression spring has 20 active coils and has spring stiffness of K. So with 20 turns, it is having a stiffness of K. Okay, so here we know the formula of stiffness, that is 8 or GD power 4 divided by 8d cube into n. So from here we understand that K is inversely proportional to n. So here we can write a relationship between these two. K1 by K2 is equal to N2 by N1. Okay, so initial stiffness is K and the final stiffness is K2, and the number of rings, the stiffness of the spring with 8 active coils. Okay, it is cut into 2 unequal parts. We are required to find out the stiffness which has got 8 number of coils. So this is 8, that is N2 is 8 and N1 is equal to 20. So here if we solve, K2 is equal to 20 by 8. 20 by 8 is 2.5 times of K. So the modified stiffness of that spring containing only 8 turns is 2.5 times of K. Okay, option C is the answer. Let's see the next question. The ball bearing has a dynamic load rating of 60,000 newtons and experiences a load of 20,000 newtons. So the expected life in million revolution. So this is a standard formula, that is C is equal to P into L, that is L power L into C into P. C is equal to P into L cube. Okay, or L here is the L10 basically it is referred to. So L10 is equal to C by P, this is raised to the power of 1 by 3. Sorry, let me correct it. So L10 here is equal to C by P whole power 3. So C is 60,000, 60,000 divided by 20,000 whole power 3. So this is 3 power 3, which is equal to 27 million revolutions. That is option C. Next, a single clutch plate transmits a torque of 50 Newton meter and coefficient of friction is 0.3, mean radius is 0.1, and what is the axial force required? So here is the formula, standard formula. Torque is equal to frictional force, that is mu times of weight, into mean radius. So torque here it is 50 and mu is 0.3, W needs to be calculated, and mean radius is 0.1. So here we get this as W, that is 0.1 by 50 by 0.1 is 500, 500 by 0.3 is that is 5000 by 3, which is approximately 1660 or 1670 newtons. So option C is the answer. Next, two plates are subjected to a tensile force of 50 kilonewton and are fixed together by means of 3 rivets. The plate and the rivets are made of same material. If the permissible shear stress in the rivets is 50 Newton per mm square, what is the diameter of the rivet? So here the force is equal to number of rivets into shear stress into shearing area, that is pi by 4 times of d square. So the force applied is 50 into 10 power 3, number of rivets is 3 and shear stress is 50 into pi by 4 times of d square. Okay, so once we solve for d, the answer, the value of d will be 20.06 Newton, sorry, 20.60 mm it would be. That's option B is the answer. So that's all, dear students, the questions from theory of machines and machine design. So I'll hand over the session to next faculty.
So we have a few questions related to the production, I can say. So here the 53 question, if you see, so which is basically related to the welding topic, I can say, right? So the brass welded using oxidizing flame due to, they are asking the reason, right? So as we know that brass is nothing but what? It's a alloy of the copper as well as the zinc, right? So here zinc having the melting point of 420 degrees centigrade, right? So whenever we are going to make the welding operation or whatever the task we are going to perform on the brass, so which causes the zinc evaporation from the base material, right? So in order to overcome this problem, we are going to use the oxidized flame, I can say, right? So the concern to that topic, we have the best option for this question, we have the option B, right? So after that, as we move on to the further, so we have the next question. So concerned to the weld decay, that is a 74 question, I can say. So the weld decay in a stainless steel due to, right? So as we see here the base metal, right? So stainless steel, which is also known as the 18/8 steel, right? So 18 is the percentage of the chromium, as well as the 8% is the concerned to the nickel, I can say, right? So here, so obviously whenever we consider the stainless steel, it will be going to having the carbon percentage also, right? So here the carbon as well as the chromium will form the chromium carbides, which makes the weld decay in the case of heat affected zone, which causes the depletion of the chromium at the heat affected zone, right? So concerned to this question, we have the answer is the option A, right? So we have the titanium also, but as per top priority concern, we have the option A is a correct one, right? So the same solution is given. And as we move to the further, we have the next question, which is concerned to the HSS, I can say, that is a high speed steel. So which is 18, 4 and 1, right? So which is the percentage of the respective elements, alloying elements, right? So which of the following option is the true for heat treatment of this HSS, right? So here the heat treatment, whatever it will be going to take place concerned with the HSS will be in austenizing stage, I can say, right? So which is around 1200 degrees centigrade. After that, it will be going to followed by the quenching or heat treatment process, right? So consider this option A is a correct one, right? So that is a thing. So here the quenching, after that it will be going to take place the tempering process. So after that we have the next question, that is the 77, which is related to the additive manufacturing process, I can say. So that is the SLS process, that is the selective laser sintering, right? So what is the typically used as the building material? So here we are going to use basically the powder metals, I can say, which may be either in the basis of the polymers, or it may be the metals, or sometimes we are going to use the ceramics also, right? So as we move to the same concept, we can recapitulate the same thing, right? So the base metal funds concerned with these processes, we have the polymers, metals and or ceramics. And after that we have the last question, that is the same additive manufacturing, I say, which additive manufacturing process involves curing liquid resin using ultraviolet laser, right? So here if we see the process, right? So that is here question concerned to the 78, right? So concerned to here the additive manufacturing process, if you take the stereolithography, that is SLA process, where we are going to use ultraviolet laser, right? So in order to cure the polymer based resin, right? So correct answer concerned to this question, we have option C, right? So the respective diagram as we recapitulate, so with that also we can make the correct option, right? So these are the questions related to the all mechanical part, right? So thank you.